Hi, Nacho. Any good stories?
Oh, your class is starting?
No, we're really.
Oh, any good stories? We were just discussing actually a lot of stories.
Your students want exams from previous years.
Oh, they do. The homework assignment is exams from previous years. That's what those questions are all from exams.
Yeah, like from the English, like the ones which you actually checked that the worded, like English exams that we wrote.
Oh.
Yeah, I put them up.
Yeah.
They're just.
But this, I told this year, nobody knows what the test will be because it's different.
But for this class?
No, different class.
No, computer architecture. It means we're all doomed.
Computer architecture.
Oh, I'm taking that.
You're not computer architecture.
Yeah, I am.
Oh, why you didn't pass
You guys
last?
doing it over?
No, I didn't take the final.
It'll be all right.
Well, actually, we taught pipelining last year.
Oh, you guys.
Yeah,
you
we did
guys.
pipelining
Yeah.
last
I taught them lucky. The Israelis are doing more Gimel now, more
They're in trouble. They gotta learn it.
They gotta learn it. Yeah.
Okay.
This is soft Yeah.
No, he was just gate crashing. He was just gate crashing.
Why am I? Oh, okay. All right, so let's continue.
Shocking. I agree. I was walking through
Wait, so you
She left. She always comes into the databases room because her office is right next to that computer.
Oh, I only noticed her in all lectures. She was like, "Hi guys."
No,
I think she
well, these are all campuses.
Where do we stop?
Not full campuses.
We were on slide 25.
I think if they're like teachable and like.
No, slide 26, I think also.
I was thinking
Yeah,
like,
that
for
was the
example, I
slide.
didn't mess up.
No, we were at 26.
Oh wait, did you go further than that?
Yeah,
Yeah, no, let's go.
Okay. So we talked about these. We talked about these steps. You need to refine the PBI. You need to estimate how long it will take. You need to wait. What is it? New items are added to the backlog. We need to create. Sometimes you need to create new PBIs, and you need to prioritize the ones that exist. I don't know why creation is not first. Okay. Effort required. This may be expressed. So how do you determine for example, the estimation of time? So you could say how many person hours or person days. The number of hours or days it would take one person to implement that PBI. It's not the same as calendar time because maybe a vacation day in the middle. And several people may work on an item which may shorten the time it takes. But it won't change the people hours. Story points. Story points are an arbitrary estimate of the effort involved.
Is that the user stories you were talking about before?
No. They were derived originally by comparing user stories, but they can be used for estimating any kind of PBI. Story points are estimated relative. The team agree on the story points for a baseline task, and other tasks are estimated comparison. This example more or less, in other words, you'll say a story point will be like, let's say you have different stories, you have different features that you want to implement. You say if this feature takes 1 point, then this feature is twice as complex as 2 points. And this feature will take 3 points. So it's a relative comparison based on a baseline, based on some past experience. Let's say in the past you had a certain feature that took you 2 days, that was a certain level of difficulty. So you can say this one is twice as difficult, this one's the same. So that'll be your story point. It's an arbitrary number of effort involved in implementing, taking into account the size of the task, complexity, technology, and anything that you don't know how you're going to do yet. You may say, well, this part I don't know how to do, we'll have to research that. So you give it a certain number of points, and so you can sort of judge the different features by how many points they are. But it's arbitrary. The number is meaningless, really. It's relative to some other task. So you only if you have like 4 or 5 different PBIs, you can say this one's 1, this one's 4, this one's 2. So you'll see which one is more or less complex. Time box sprints. Products are developed in sprints, each of which delivers an increment of the product or the supporting software. Sprints, we said, are 1 to 4 weeks. During a sprint, the team will work on items from the product backlog. That's already, we said that. Benefits of using time-box sprints. There's a tangible output that can be delivered at the end of every sprint. In other words, we have demonstrable progress. We know that we got something done. See, if you don't work with sprints, then what are you going to have? You're just going to have kind of like endless work until eventually you have a final product. You don't feel like you've done anything along the way. So here you have demonstrable progress. You have a work plan. The team develops an understanding of how much work they can do in a fixed time period. They start to pat they can pat themselves on the back. They can say, we can get a feature done, or we can get 3 features done in a week. That's amazing. You sort of realize what you're capable of. Problem discovery. If errors or omissions are discovered, the rework required is limited to the duration of the sprint. In other words, if you're trying to fix a bug, you're going to not fix it forever. You're going to finish it in a sprint. And also, you probably will discover bugs faster because you're already getting things out there to be tested, to be used. They used to make a joke that Bill Gates used to ship programs that were so buggy, so that Microsoft programs were very buggy in the beginning. So they would say that his quality assurance staff is the customer. Right? The customer is his quality assurance. Sprint planning. Work items can be completed in that. The work items that can be completed in that sprint are selected and, if necessary, refined to create a sprint backlog. Now, that's the list of all the things that you want to do in this sprint. This should not last more than a day at the beginning of the sprint. Now, you shouldn't spend more than a day creating that list and refining them. Sprint execution. We talked about this. The team work on implementing the sprint backlog items. The unfinished items are returned to the product backlog if we couldn't finish them. In other words, we'll choose a subset of the product backlog to do in this sprint. If we see we can't finish them, then we'll put them back in the backlog for the next sprint, or for some other, or for 2 sprints from now. Sprint reviewing. The work done in the sprint is reviewed by the team and possible external stakeholders. The team reflects on what went well and what went wrong during the sprint with a view to improving their work. In other words, maybe there was not good communication. Maybe if I had known what you were doing, then maybe I could have. Maybe there was we did the same work twice. You and I both tried to do the same thing, and if we'd known what each other were doing, we could have saved time. Sprint activities, planning, creating a sprint backlog, and then sprint review, and then you have sprint execution, actually doing it, and you have the Scrum meetings. We did this already before. Integrate. You take things in the Scrum meeting. See, this arrow means that in the morning meeting, you take things from the backlog to be done today. And remember, the sprint backlog was created from the product backlog. Sprint planning. Establish an agreed sprint goal. Sprint goals may be focused on software functionality. Decide on a list of items. Create a sprint backlog. We said sprint goals. Implement user roles so that a user can select their role when they log into the system. These are just examples. These are examples of certain goals that you might have. For example, you might have a functional goal, which might mean that it's certain functionality. You want them to be able to log in. You may have a performance goal. You may have a goal in your sprint to improve the performance of how much the system can handle. That could be also a goal, not necessarily a feature. It could be just a reliability. Or you could have a goal of creating documentation about your program. How much to figure, those could be different goals that you might have in your sprint. They don't have to all be functional. Functional is what we're talking about up to now, a new feature. In a sprint plan, the team decides which items in the product backlog should be implemented. We said that key implements are the effort estimated associated with the PBI, the output is the backlog. So we're producing a backlog. That's the planning. And then the backlog is what we're going to do. The sprint backlog is a breakdown of the PBIs to show what is involved in the implementing the PBI chosen from that sprint. In other words, we may say this feature, we may actually define all the parts of that feature. We may not just say, do this feature, go. We may say, what are the parts of this feature that have to be to get it done? And that may be part of the planning. During a sprint, the team have daily meetings. Okay. Didn't we read this already? No?
Just a lot of, it's just repetitive.
It's just repetitive. Scrum is a short daily meeting. Short and focused. There should be 15 minutes long. No chairs. This is an idea. There's no chairs. You stand at a scrum meeting. That's also why it's called a scrum, because in the rugby you stand. You review the sprint backlog and see completed items are removed. New items may be added to the backlog as new information emerges. As theoretically, you shouldn't be adding any new items to the sprint because you already did that in the planning stage. But you might have to add something because you found out that you can't do the thing you want to do unless you do some other thing. So then that would be the only case that you would add things to the sprint, right? If the thing that I already added is dependent on some other thing which I hadn't thought of, and now I have to add that thing too. The team then decides who should work on the items in the backlog. That's what I said, the team decides. In other words, the way we did it, you decide for yourself. Although it might come out that your coworker says, Nachum, maybe you can do one with, you know, I got 6 and you only got 1. And I'll say, no, I can't do it anymore. Scrum does not suggest the technical agile activities that should be used. However, I think there are 2 practices that should always be used. So here it's saying 2 technical things. You should. He's advising, or he's saying that probably you should always do test automation. In other words, don't have human beings test your program. Have programs to test your program, like you did in test-driven design, test-driven program.
How would you have humans test it as opposed to, like, does he mean having a human write a program to test it? Because it can't be fully autonomous. Again, someone has to create it. So at what point does it stop becoming a human testing it and it being automized?
No, the question is, do you have a list of features? In other words, normally you have a, what is it called? A test book? Test, there's a term for this. I think it's called a test book, where you write down, all right, make sure that you can, upload a movie. Make sure that you can upload a music video. Make sure, upload a picture. Now make sure you can edit a picture. You have a list of all the actions. Click on this button, then click on this button, then click on that button. And you have a list of what the human being should do. If you have such a list, then I call that human testing. If you don't have a list, but you have software that does those things for you, that uploads a picture and uploads a movie and does all those things, then it's not human, then it's automated. It may be that a human being runs the automated test, but that's still called automated test. Whenever anyone makes changes to the software component they are developing, these components should be immediately integrated with the other components to create the system. This system should be tested and checked for authenticity. Whenever anyone who makes changes to the software components they're developing, what is he talking about here? How would somebody summarize this paragraph? What feature is he talking about that you've used? Some of you have used? Yeah, Git. He's saying here, Git. He's saying every time you make a change, update it on Git. What's the point? You have a team of 10 people. You're all updating to the same repository. I'll see the changes that you made, and I'll have to work with them. It's happened to me that I created a new table in the database for some data that I needed for some feature. And I created it on my own, and now I have to integrate it back into the Git repository. And as I go to integrate it, I see that somebody else has created a similar table with the same data, but a different name. He created his own table. So then I say, well, we shouldn't have 2 of these. He says, well, I committed first, so that I have to go rewrite my program to use his table, because I'm not going to have 2 tables with the same information. See what I mean? So that's the kind of conflict that you can have. But you'll find that out the same day if you're constantly integrating. Actually, that's a good point. The minute you make a table, you should and before you even start using the table, you should already upload it, because then you don't want to start working on a table and then find out that you're going to probably have to remove it. Okay. Code completeness checklist. So these are the things that you should, if you before you can accept a program, you have to have these stages. Review. Now this is an interesting step here, which not everybody does, but is called a code review, where another team member looks at your code and agrees. This is actually what you were talking about, and agree to coding standards. In its understandability of your code. He looks at this, what the heck does this do? And then he says, oh, okay, it's okay. The way you did it is okay. Or maybe he didn't follow standards. You have a function that's 10 lines long. That's our standard is we don't have functions that big. You know, whatever, he'll look at your code and he may tell you go and refactor it. Refactoring, the way I first encountered it was you have a function that's very long and you refactor it into several functions. So you take the same function, you divide it up into 2 or 3 functions, just to make it more clear. What do you gain by making it small? In a certain way, it makes it more complex, because you have to look at this function and that function and that function. But in a certain way, it makes it clear because each function has a name, and the name tells you what it does. So then you can sort of see the progress of what I'm doing. Okay, I'm doing this, and I'm doing that, and I'm doing that. And by giving the name, by giving a good name to your function, you have what's called self-documenting code. Code that you can read it as English and you understand what it's doing, because each name of a function is telling you what it's doing. So as long as those names make sense, the code will make sense. He may tell you need to comment your code, and maybe you need to refactor it, as I just said. That's the review. The unit test is done automatically, as said, and that they've passed all the tests. Integration. So this is before I integrate it. I tested that it works. Then the code has been integrated with the project code base and no integration errors. So that's what you call merging or something like that. In other words, it integrates properly. No duplicates, tables or something, or a function. I mean, I use a function name and somebody else happened to use the same name. All integration tests have been run and automatic tests have been executed, everything works. That's integration testing. So I review the code, I test it. I mean, you could do this in the opposite order. In general, I would say the order could be different here. You first test it, and if it works, then you show somebody your code, and then he changes it, and then you test it again. And then you integrate it, make sure that it integrates properly, then test it now together, and then acceptance. Acceptance tests have been run if appropriate, and the product owner or the development team confirm the product backlog item. In other words, acceptance test means like your feature doesn't break anything, it's written well, doesn't cause any problems, but guess what? It doesn't actually do the feature the way we want it, or it doesn't do it at all. It doesn't do the feature. That's acceptance tests. Make sure that what you did actually, not only is it not damaging, but it's also solving the problem. Sprint reviews. At the end of each sprint, there's a review meeting. Review whether or not the sprint has met its goals. Okay, did we meet our goals? Sets out any new problems or any issues that have emerged during the sprint. I noticed that we needed a person who knows more about databases in our team. The product owner has the ultimate authority to decide whether or not the goal of the sprint has been achieved. In other words, the product owner or the product manager will say, you know what, you didn't actually finish the feature the way, the sprint's not over. You gotta keep working 2 more days. It's not the feature that I wanted. Or the features that you added are wrong, or something wrong about them. They should confirm that the implementation of the selected product backlog item is completed. Did they really do it? Maybe they say they do it, but they didn't do it. The sprint review should include a process review in which the team reflects on its way of working and how the Scrum has been used. Now, this I've never seen people do, but maybe you could discuss whether you've been working well together. I don't think this team is working well together. I don't understand what other people are doing, or they're not talking to me. The aim is to generate ways to improve and discuss how to use Scrum more productively. I don't think the Scrum meetings have been lasting too long. We're spending our whole mornings on Scrum meetings and I get no work done. So that would be something in the sprint. That would be in the sprint review. We're actually reviewing the sprint. Sorry. Self-organizing teams. What does that mean? Well, we talked about this. Consensus. Everybody discusses things. They figure out who should do what among themselves. They don't talk to managers and customers so much. They just talk to themselves. The managers maybe sits in on this, I mean, the manager can maybe talk to them a little bit, but limits the involvement of other people who are external. Makes its own decisions on schedules and deliverables. As we tell the manager when we're going to finish the sprint, not the manager tells us, right? We know the program. We know how long it takes us to work. We'll tell him when we're going to finish. If he says, no, I want it done in 2 weeks, then we'll say, well, then you got to remove stuff from your sprint list. Team size, 5 and 8 people, between 5 and 8 people. So the people should have different skills. Usually, have you ever heard the term a back-end developer, a front-end developer? And then there's people like to call themselves full-stack developers.
Can I ask you a random question about back-end and front-end?
Yeah.
Do they happen in 2 different languages and then what put them together? Since front-end languages and back-end languages, I've never understood like what's the point where you get the back-end and the front-end working.
Well, usually, let's say the back-end is written in PHP, or Python. The front end will be a combination of Python and then other things like JavaScript.
How do you combine two languages?
Because in the front end you can do that, because like when a web page loads up, it'll run JavaScript. Now the PHP will generate the text of the page, but then there'll be JavaScript that will, part of the text that it will generate, actually the way you do it is like, sometimes you do it like this, the text that it will generate will actually be Java code, JavaScript code. Then you'll have cout, quote, and then a whole long line, which is actually JavaScript. And then that will be the page. So the PHP is writing that page, is writing that line, and then that line goes to the browser, and the browser then runs that line.
Right now, there's platforms that can use like Angular, let's say, and then just have different pages of code in some languages in one project.
What is it called?
Angular?
I don't know what it is. Okay, but yeah, there could be. I'm just telling you one way, yeah.
So is there someone who does that, or the front-end guy?
No, the front end guy does that. The front end guy uses the back. The front end guy has to know enough about the back end to be able to use it.
Does the back end need to know much about the front end?
Not really, less actually. He has to know what the front end wants, what data he knows. He knows how to present the data to the front end.
But not how the.
But he doesn't actually. No, the ultimate, right? The end of the chain is the front end. So he has to know how to use the stuff provided by the back end.
So what does a full stack guy do?
So when they call themselves a full stack developer, it means that they know how to do front end and back end. They can do everything, and they can even set up your servers for you, theoretically. They can do. It's like a vertical monopoly. They can do from 0 to the top. They can do everything. But I think, and there are people that do that. I wonder though, yeah. It usually should only say that about yourself if you've actually done that. Not that you've worked in the back end in the past and you've worked in the front end in the past, but that you've done a whole project yourself. So that you've actually integrated the whole thing.
What's better to you?
You guys should probably do back end. You
You haven't learned any front-end stuff.
Yeah, you don't. Yeah, we don't really learn much.
Different computer science degrees
Kind
training
of like
for
full stack just to know front end also.
It could be, yeah. I don't know. Front end would be writing
You
like
can use stuff like Java.
JavaScript. But yeah.
Java could be the one.
Java is different from JavaScript. They're two very different
Yeah,
things.
but can't you use Java for front end? As in stuff like color, functional, and you can develop an app purely using Java. Yeah?
I might be wrong.
I don't. Well, when you talk about front end, I'm talking about like on a web page. So it's usually going to be
Just
this.
JavaScript.
It's usually JavaScript because that's what the browser can run. If you're talking, there's 2 different things. You see, it's complicated.
Do different computer science degrees,
What?
do different computer science degrees train you for either back end or front end?
You need
No.
something to like load pages.
The
You're
truth-
saying we would be better in back end.
I was like, looking at that, okay, programs.
Well, I don't know other schools, so I can't really answer. But I'll say it like this: there's a core curriculum of computer science, which is which is like data structures and all and the theoretical stuff. And then there are optional additional courses. And in our school, they're mostly back end. Those optional courses in another school could be front end.
What's optional?
Yeah, Unix course. Also that course that you did the course they do in the mini project and introduction to
Yeah, we're doing a mini project now.
the mini project. You didn't do any. Also, you learned a front end person. I worked with a front end person who doesn't know C++ at all.
Yeah.
Front end persons are a lot of times self-taught. They're people who like computers.
Is front end easier than back end?
I wouldn't say. It's not easier. It's just a different place of programming. You're more involved with they didn't have a graphic. Now there's the basic team. The basic team is going to be a graphic designer, a front end person, a back end person, and then like a server person to deal with like the infrastructure. Make sure that's your basic structure. Obviously, graphic designer is totally different. We mostly do back. In school, people who went to a 4-year school should be doing back end in general. But you can teach yourself front end. That's the thing you teach yourself. We got to finish this. Class is over. Well, let me just see if there's anything important. Product management. You should have project management.
Yeah,
All right, we finished that.
That's sick.
Class is over? Okay.